Let's go down here. And this is a similar concept. We can see this as a whole system. We really zoom out and say, well, you know, first of all, which way is the system going? Can you really be sure? Is it going that way or this way? You know how I find out? First of all, it's very nice. That's frictionless. That's great. So which way is it going? Is it going clockwise or counterclockwise? All I have to do is find the parallel component of the 1 kilogram, F parallel of the 1 kg, and that is 10 newtons, multiply by 10, sine, parallel component is sine, and that parallel component is 5 newtons. So now I know my system is going this way because it's the clockwise force is 40, the counterclockwise is only 5. My system's going this way, and I'm going to call that the positive direction because I found the parallel component. There are two competing forces, 40 newtons in this direction and 5 newtons in this direction. Now I know for sure that this object is going in the clockwise direction, so I'm going to call it positive. Now, this tension equals this tension. We have a massless pulley, so let's find, well, N, F, A, T. No friction. I can't find the tension until I get the acceleration, and, well, you know how to do that. And F equals ma. So there's the positive force of 40 newtons. There's the negative force of 5.0 newtons. We're zooming out. We're saying there's a positive force on this system of 40 newtons and a negative force of 5. And what is it accelerating? It's accelerating both masses, not just one mass. These two competing forces are accelerating both masses. So that's 35 newtons equals 5.0 kg equals A, and A is 7.0 meters per second squared. Now, why did I find that? Well, because before you can, oh, good, I got that right. Before you can find the tension, you need to know the acceleration. So now we can do it. Now we isolate. I think it's a heck of a lot easier, I think, if we isolate on this and have, what's that? Tunnel vision. So we isolate on that and we do F equals ma on that. So sum of the forces in the, y direction equal ma in the y direction. So what are the positive forces? Well, we call this positive, so it's 40 newtons minus t. What is it accelerating? Only the 4.0 kg mass. And we've already found that 7 meters per second squared. So 40 minus t is 28 newtons. So 40 equals 28 plus t, and t is 12 newtons. I'm going to peek to see if I got it right. Yep, got it right. Good. And then we'll put a box around it. I think we should always do that. So once again, we're using this method that you could call a whole system method, where you have multiple bodies in your system, and you say, well, what are the competing forces? Which way is it going to go? I found the parallel component, and I realized that there's a force that's going counterclockwise of 5 and clockwise of 40. So I've established my positive and negative. This system is going to go clockwise. So that's what I call positive. And then to get my tension, I need my acceleration, and I use the whole system method to get the acceleration because I have the forces that are on the outside of the system, 40 going down this way and 5 newtons going to the counterclockwise. I find my acceleration. Then I isolate on the 4 kilogram because it's easy. And I got the answer of, again, 12 newtons. Good. Okay, I want to, let's go through another one. This one has friction. So that makes it tougher. N, F, A, T. Got to find the normal. That's really easy. sum of the forces in the y direction equals 0. So the ups equal the downs. Terrific. And then I find my friction. Friction equals mu times normal, which is mu's 0.2, 0.50. I'm going to give it 2 sig figs times 20 newtons. The friction equals 10 newtons. Is that right? Yeah. Okay. So now I look at my whole system method. I use my whole system method, and I see, which way is this system's going. It's very clear to me. Well, is it clear? I'm not sure, but I'm thinking it might go this way. However, it might not even move at all. Let's see. There's 10 newtons going. It's going to oppose motion. So this is 30. Yeah, I think it would go in that method, right? Because friction is 10 newtons. This one's going to act this way. Yeah, this system's going to go to the left because this is 50 newtons. So this friction's going to go to the left, right? 30 newtons puts it clockwise. 10, I'm getting sloppy again. 10 newtons so 10 newtons is counterclockwise, 30 newtons is counterclockwise, and 50 is clockwise. This system's going to go in this direction. We'll call it positive. Whew. Okay, so now how am I going to get my tensions? Well, I have to recognize that this tension, we're going to have to call T1. This is also T1, and this is T2, T2, and T2. Boy, okay, so we've got our friction. We've got a direction. Now I have to find the acceleration. I can't get my acceleration unless I can't get my tension unless I get my acceleration. And we use the whole system method. And we say there are 2 competing forces on my system. Three. There's the 30 going counterclockwise. There's the friction 10 going counterclockwise. And there's the big counterclockwise force of 50. Let's do some of the forces in the counterclockwise direction equal ma. So there's a positive force of 50 newtons. There's, remember, 5 times 10, and there are 2 negative forces: the friction 10 and the hanging weight 30 newtons. Now what are they accelerating? All 3 objects will move. 3 plus 2 plus 5, 10 kg. 10 kg times A. So 50 minus 10 that's 10 newtons equals 10 kg times A. Let me see if I got that right. I have the answers actually put down. What, right? 1 meters per second squared. I'm going to make it A is 1.0 meters per second squared. Now I got my acceleration. Now I can get my tension. So I'm going to make my life easy. I'm going to isolate the hanging weight for T1. Isolate this and have tunnel vision. So what are the positive forces on the 5 kilogram? That would be 50 newtons. What's the negative force? T1. What are those 2 forces accelerating? Only the 5 kilogram mass. That's a little hard to see. Let me be a little careful. Let's erase that. The 5 kilogram mass. 5.0 kg. And we already found it's 1.0 meters per second squared. So 50 newtons minus T1. 5 times 1 is 5 equals 5 newtons rather. 5 newtons, 5 times 1 is 5. So T1, so 50 newtons minus equals rather T1 plus 5 newtons. T1 is 45 newtons. T1 is 45 newtons. And I'm going to take a look if I got it. Yep, got it. Okay, now to get T2, we're going to have to, I'm going to have to get a little room, make a little room here. And we'll isolate on the hanging weight, the 3 kilogram hanging weight, knowing that the acceleration of the system is 3 from before, 1 meters per second squared. So now I'm going to isolate again. It's really good to isolate to get tensions. T2, so sum of the forces in the y direction equal ma. What's the positive force? Well, T2 is, look at T2 over there. It's going in the direction we call positive. 30 is going in the direction we call negative. Equals m. What are those two forces accelerating? Only the 3 kilogram object. And what acceleration does it have? 1.0. Let's erase that. Get some room here. 1.0 meters per second squared. 1.0 meters per second squared. So T2 minus 30 newtons equals 3 newtons. T2 equals 33 newtons. Equals 33 newtons. Let's once again clean that up. So T2 is 33 newtons. And I'll see if I got that right. And I think I erased everything. Yeah. T2 is, let's double check. T2 is up in the positive direction, 30 is down. 3 times 1. Good, looks good to me. I think I erased my answers, but I think that's correct. So now let's see if that makes sense. If the system is going in this direction, does that make sense? Yeah, it makes sense that T2 is greater than the weight force. They see the weight force is 30. I always like to double check. Does this make sense? Yeah. This is T2 should be bigger now because it's accelerating to the left and increasing the tension here, making the tension greater than the weight force, and that's why it can accelerate the other way. Now let's look at our T1. Does that make sense? I think, did I erase my, yeah, T1 is 45. Yeah, the T1 is less than the weight force, and that's why the 5 kilogram can accelerate down. And I think that's all we're going to do here.